This is lesson 8-4, area of regular polygons. And this is a quite short lesson that kind of builds upon the past 3 lessons where you'll need to know how to work with parallelograms, triangles, trapezoids, and probably rectangles and squares will come into play as well. So basically a regular polygon is a polygon in which all sides and all angles are congruent. So you can decompose these figures into other shapes, and you can therefore find the total area based on those formulas that we already know for those shapes. So here is a video example.
A regular polygon is a polygon with all congruent sides and all congruent angles. This hexagon is a regular polygon. Each side has a length of 2 centimeters. To find the area of a regular polygon, first decompose the figure into triangles, parallelograms, and trapezoids. The hexagon can be decomposed into 2 congruent trapezoids. Next, find the area of the polygons that make up the hexagon. Use the formula to find the area of the trapezoids. The area of the trapezoid is 5 19/100 square centimeters. The 2 trapezoids are congruent, so the areas are the same. Finally, you can find the hexagon's area by adding the area of the polygons that make up the hexagon. Because the trapezoids are congruent, the areas are equal. So, the area of the hexagon is 10 38/100 square centimeters.
Amazing. So you also can break this into 6 triangles if you wanted to do it that way, but that gets a little complicated because of like height situations and things like that. Is there another way to decompose it? Yeah, there is. Triangles. All right, so let's look at example 1. There's actually only one example, so we'll just look at this one and then we'll be done. Find the area of regular polygons. A stop sign is shaped like a regular octagon. Octagon meaning 8 sides. Each side of the sign is 15 inches long and measures 36 inches between parallel sides. So that's the parallel sides are this one, these ones are parallel, these ones are parallel, and the distance between those is 36 inches. So let's find the area by decomposing the octagon into congruent triangles. So let's look at how to do that. We can split across the middle, and then we can split across the middle at all of our vertices here. So how many triangles does that give us? 1, 2, 3, 4, 5, 6, 7, 8. That makes sense because there are 8 sides in an octagon. And that's just a better visualizer there for you so you can kind of see how they break down. So once we have our triangles, we can find the area of each triangle using our formula area equals half times base times height, or area equals base times height divided by 2. So these 15 and 18s, where do they come from? They come from the original piece of information that told us that each side of the octagon was 15, and so that's going to be the base of our triangle is also 15. And then they also told us that the distance between parallel sides was 36, but we're only going halfway across to complete our triangle, so halfway across is 18. So then we have half times base times height here. And so if you were to math that out, you would end up with 135 square inches. 15 times 18 divided by 2, or 15 times 18 times 1/2. Yay! Okay. So then that's just the area of one triangle. So we want the area of the whole octagon. So here's what we need to do here. The triangles are congruent, so we can multiply the number of triangles, which we counted, and it was 8, by the area of each triangle. So we had 8 times 135, and I literally don't know the answer to that in my head because I can't do math in my head right now. 135 times 8 is 1080. So that would be the total area of the stop sign or the octagon. And basically that's it. So you just have to kind of pick what shapes you want to divide or decompose your polygon into. If you see trapezoids, you can go for that. If you see triangles, you can go for that. If you see rectangles, you can use that. You can use parallelograms. Sometimes it will be like combinations. It just depends on the polygon. And you get to pick whatever you want, and then just make sure that after you find the area of each of the individual figures that you've decomposed into, that you don't forget at the end to add them all together or multiply them, so that you can get your total area of the official shape that you were looking for the area of. That's it. I would like you to complete the apply and the check that goes with this, in addition to the check at the end of example 1 here. So do the check for example 1, then the apply, and then the check for that as well. And that's the end of lesson 8-4.